Welcome back to Math Expressions with Ms. Hasty. Today we are on Unit 7, Lesson 5, and it is reading points. Okay, so we're going to be learning about coordinate plane, y-axes, x-axes, ordered pairs. Let's go ahead and start on page 295 in your activity book. So please go ahead and turn to that and we read along with me. Okay, reading points. A coordinate plane is formed by the intersection of a horizontal number line, called the x-axis, and a vertical number line, called the y-axis. We're going to use the coordinate plane below to answer the questions. This is an example. Number 1, an ordered pair is used to describe the location of any point in the coordinate plane. For example, the ordered pair 9, 5 describes the location of point A. So if you find A, it is over 9, up 5. Okay? The 9 is going to go along the x-axis, and then the 5 goes along the y-axis. So always remember x, y, x is first, y is second. X, you're going to be moving over, and y, you're going to be moving up. Okay? An ordered pair consists of two coordinates, okay? A, the first coordinate represents the distance along which axis? So the first one is along the x-axis, which is your horizontal line, all right? The second coordinate represents distance along which axis? The second one is the y, and that would be the vertical. So that when you go up, x goes across, always goes across first, and then y you go up second. 2, the origin of the coordinate plane is the point at 0, 0. Why is the origin an important point? Because you always want to start from the same place. Okay? You always start from the same place. Or same point, which would be your 0, 0. So if you always start at 0, this one, for example, you go over 9 and then up 5. Okay? So let's do some of these together. And make this a little bit bigger so I can see it. Alrighty. So number 3 here, we have point B. So find B, and remember, you're always going to go over first and then up. So to get to coordinate point B is over 3, up 3. Parentheses, comma, parentheses. Okay, let's go to point C. Point C is up here. Over 9, up to 10. 9, 10. Parentheses around them. Number 5, point D. Over to 8 and then up 1. 8, 1. Number 6. Here's point L. Now look at this closely. L doesn't really go over, but it goes up because it's on this axis right here. It's on the y-axis. So that means it didn't go over any. So it goes over 0, but then up 7. Okay? Number 7, point M. Let me erase that line there. Okay. Back to our pen. All right, number 7, point M. Here's M over 6, up 5. The eraser's still on. Okay, put that 3 back. Over 6, up 5. Point N. Here's N here. It goes over, but it doesn't go up. So that means your X is 5, your Y is 0. Number 9, point R over 2, here's R here, over 2 and up 6. Oops, sorry. It said one way and then I wrote the opposite. Okay, so again, R is over 2 and then up 6, 2, 6. And point S, our X is going to be over 7, Y coordinate would be up 8, 7, 8. Okay, let's go ahead and turn the page and do the opposite, where we are going to page 296, and we'll have our Y and X, and then we have to plot them. Go to page 2 here. Okay, use the coordinate plane below to complete exercise 11 through 25. Plot and label a point at each location. All right, so here we have number 11, point J at 5, 4. Remember, always go over first. So X and Y over first and then up. So 5, go over 5 and up to 4 and label that J. Number 12, point Q at 1 and 9, over 1 up to 9 and label that Q. 13, point Y at 2 and 0, so over 2 and it doesn't go up at all. So the Y is at 0. 14, point W over 0, up 4. So it stays on the Y axis there. Point K, 4, 5. So over 4, up 5, and there's your K. 16, point R, 8 and 3. Over 8, up 3, always over first, and then it's going to be R. 17, point B is at 6, 1, over 6, up 1, and label that B. 18, point V at 3, 8, over 3, up 8, and that will be labeled V. 19 is point L at 10, 0. Over 10, it doesn't go up at all because of the 0, so that's labeled L. 20, point P at 7, 10. Over 7, up to 10, and that is point P. 18, point V at 3, 8. Over 3, so X is 3, Y, oops. Might be at 3, 8. I did that one already. No, we did that one already, sorry. Okay, 21, we're at point C. We did P, okay, C. Point C at 0, 6. Over 0, up 6. And 22, point Z, 9, 7. So over 9, up 7. And that is point Z. Okay, so now that we have all of those plotted, tells us on the coordinate plane above, draw an angle of the given type. The angle should have its vertex at one labeled point and sides that pass through two other labeled points. Give the name of the angle. So we have acute angle, which is smaller than a right angle. Okay, we have an obtuse angle, which is larger than a right angle. And then we have a right angle, which is 45 degrees. Straight up and down. Okay, right angle. All right, so I am going to change colors here so it makes it a little easier to see. And let's see if we can find an acute angle. Well, one acute angle might be this QVC here. Okay, So that would be angle QVC. That's acute. It's smaller than a right angle. Okay, and an obtuse angle. This looks like a nice obtuse angle, this PZR. If you look at that angle and you connect the three, that's angle PZR. And a right angle. Let's go with this angle here, CWJ makes a right angle. So we have the right angle right there. CWJ. Okay, that completes page 296. Let's move on to the third page. Okay, we have a puzzled penguin. Now there is one in between there. Let's go ahead to this page here. Horizontal and vertical distance. Okay, so we're going to plot some here, and then we're going to find the distance of a segment. Okay, we're going to plot a point at 110 and label the point A. So 110, we're going to label it A. And then plot a point at 17, over 1, up 7, label that B. Plot a point at 810, over 8, up 10, and label that C. And plot a point at 8, 7, and label that D. Connect the points to form a quadrilateral. Here we have a quadrilateral. Quadrilateral is 4 sides. Okay. Explain how subtraction can be used to find the length of line segment AB and AC. So if we want to know, let me change colors here again. If we want to know the distance of segment AB, okay, AB equals, you're going to take the coordinates of, so A is at 10, and B is 7, so we're taking our y coordinates, and that equals 3. Okay, so segment AB is your y coordinates, 10 minus 7 equals 3. Okay, so if we want to know AC, segment AC, that's here to here, right? You're going to take your x coordinates, which would be 8. So here's C, minus A, which is 1. That equals 7. Okay. Number 28, in the coordinate plane above, draw a rectangle that is not a square. So you would just draw another one that is not a square. So you don't want 4 equal sides. Okay, draw another one. What ordered pairs represent the vertices of a rectangle? And then you would come up, what are our ordered pairs here? Okay, my first one is 4, 1. The second is 10, 1. And I have 4, 4. And 10, 4. And could I do a subtraction equation to represent the lengths of the rectangle? It would be the same as here. You would label the 4. So this could be E, F, G, H, and find the segment of EG here. I would be taking 4 minus 1. Okay, and if I want to find EF, it would be 10 minus 4. Okay, a little bit on line segments and how you calculate along. All right, our last page today is a puzzled penguin that we're going to be doing together. Let's see if we can figure out what he did. I was asked to name the location of a fourth point that would form a square when the points are connected by the line segments. I think the point 7, 4 would form a square. Do you think that is correct? So take a moment and take a peek at that. Here you have 8, 3, 4, 3, 8, 7. Okay, and he said 7, 4. Hopefully you realize that he mixed up his x and his y coordinates. It needs to be 4 and then 7. That would make the square. Okay? All right, let's move on to our homework side and go over a few of those. Use the coordinate plane below to answer the questions. So just like we did in our activity today, number 1, 2, 3, and 4, you are going to always remember x first, then y, over, then up. Okay? Find the point and tell what the coordinating points are. 5, 6, and 7. All right? Plot the points and label them. And then number 8, suppose points W, X, and Y represent 3 vertices of a rectangle. Where would point Z go? So once you have these plotted, remember you want to make a rectangle. So you'll have 3 of them, and then you're going to have to decide where would the 4th go to make that rectangle. Plot and label point Z, then use a rule to draw a rectangle. Number 9, what ordered pair represents the point at the center of the rectangle? Well, once you have your rectangle drawn in your coordinate plane here, you're going to find the center. And then what would the points be? What would your x and your y be in that center? And 10, use subtraction to find the length segments of WX and XY. Show your work. So what would the equation look like? Well, back to our activity to help you with that. Okay, 7-5 remembering. Here we have some division problems with decimals. Remember, for decimals, you want to get rid of the decimal on the outside. In this case, you would add 1, and you're going to move this over 1, so you move this over 1, and you'd rewrite that. Okay? If there isn't a decimal on the inside, you're going to add 1. This one, you would move over 1, rewrite, add a decimal to the inside. If it is not there, move them accordingly. And always check your division with multiplication. More remembering, write a first 5 terms numerical pattern that begins with 5 and then add 6. Couple lessons back to help you with that. Write an expression for the 6th term of the pattern. C, write the 6th term. And then 8, stretch your thinking. List and graph 4 ordered pairs that are vertices of a rectangle with a perimeter of 16 units. Okay, so remember what perimeter is. If you were to add all the units all the way around, they would add up to 16 all the way around. So let's see what you come up with for that. And we'll post the answers for you to check your work. Alrighty, boys and girls, that is 7-5. Good luck on it, and we will see you tomorrow for 7-6. Thank you.